Good afternoon, all of you, dear students. In the last class, we have seen about petrochemicals like xylene and propylene oxide. There are four more petrochemicals should be discussed. We shall see that the four topics in the next class. In this unit, the remaining topics, that is liquid and gaseous fuels, comes under unit 1. Today we shall start unit 1. In this unit we shall discuss one by one. First, definition of a fuel. Generally, fuels are combustible substances which contains carbon as a main constituents, which on proper burning gives a large amount or enormous amount of heat, which is used as a domestic and industrial purpose. The fuel is a combustible substance which is containing mainly carbon, which on proper burning gives or liberates a large or enormous amount of heat, which is used for domestic and industrial purposes. Examples: wood, charcoal, coal, kerosene, petrol, diesel, water gas, producer gas, oil gas, etc. This all comes under fuels. These fuels may be either solid or liquid or gaseous fuels. Let us discuss it about by writing an equation. Fuels burn in air, that is fuel plus O2, gives products and amount of energy. Fuel plus O2 gives rise to products plus heat, or heat is nothing but amount of energy. Here in this fuels, we should know about fossil fuels. The fossil fuels are nothing but the fuels which are available in Earth's crust. The fuels which are available in Earth's crust are known as fossil fuels. Next, third topic, classification of fuels. Generally, we have written in a flowchart, fuels are classified into two types. These are classified according to their occurrence and according to their state of aggregation. According to their state of occurrence, they may be classified as primary and secondary. Primary fuels are also known as natural fuels, and secondary fuels are also known as synthetic fuels or artificial fuels. These primary fuels are natural fuels which occurs in nature. For example, wood, coal, natural gas, crude oil, dung, etc. And secondary fuels are those fuels which are prepared from primary fuels. This may be charcoal, coke, kerosene oil, diesel oil, petrol, coal gas, water gas, producer gas, etc. The fuels which are prepared from primary fuels are known as secondary fuels. Primary fuels are nothing but natural fuels which are obtained from nature or which are found in nature. And this is explained according to the flowchart diagram. In this flowchart, primary or natural fuels are classified. That means not classification. Primary fuels may be solid, liquid and gaseous. See here, in solid primary fuels, wood, coal and dung, these are solids which are available in nature. And liquid fuels, crude oil. Crude oil is also available in Earth's crust. And gaseous fuels are nothing but natural gas which is available in Earth's crust. These three, solid, liquid and gaseous fuels, are obtaining from nature. And the secondary fuels are derived fuels which are obtained from primary fuels. Also may be solid in nature, liquid in nature and gaseous in nature. These solid fuels are examples: coke and charcoal, and the liquid fuels are kerosene, diesel oil, petrol, LPG, And gaseous secondary fuels are coal gas, water gas, and natural oil gas. After this classification, we shall see about calorific value. Calorific value is nothing but the amount of heat liberated when a unit mass of a fuel is burnt completely. This may be denoted by calories. Calories are kilocalories. Once again, calorific value is nothing but the amount of heat liberated when a unit mass of fuel is burnt completely. It is expressed in calories or kilocalories. And finally, there are 10 to 12 characteristics for a fuel which is there are 10 to 12 characteristics for a good fuel. We should remember one: every fuel which is having 100% efficiency should have high calorific value. It should not have moisture content. It should have a moderate velocity. It should be cheap and it should be easy to transport and should not undergo spontaneous combustion. When a fuel which is burnt in air, it should not produce much smoke. And in case of solid fuels, the size should be uniform so that the combustion is regular. Once again, a good fuel should have a high calorific value, a moderate ignition temperature, and it should have a low moisture content. It should be cheap. It should be easy to transport. It should not undergo spontaneous combustion. When burnt in air or when burned in air, it should not produce much smoke. And in case of solid fuels, the size should be uniform so that the combustion is regular. These are all the characteristics for a good quality or good fuel. Thank you.